Hi, this is Grover with Blue Collar Codes, the quick and dirty, episode 17. Gonna give an overview of exceptions and error handling for beginner level, and briefly touch on try, except, raise, and finally keywords. So if you wish to follow along, you can find episode 17.py in the GitHub repository, which is linked in the video summary. So first of all, I'm going to give a layman's terms definition or explanation of exception handling in Python. And basically, exception handling allows you to choose what happens to your program when an error occurs. So you can wrap certain chunks of your program and code in a try except block, and then if an error occurs within that try block, then you can handle them specifically by catching specific exceptions and then handling them or executing code within the except block of code as you see fit for your program and the situation at hand. So outside of that, we're going to go over just the fact that exception class tree exists. You have base exceptions, and then it gets to varying degrees of specificity for certain errors. So value, lookup error, arithmetic error, zero division error, and so have you. So just be aware that that exists. And then when you want to start creating your own classes and you have a larger OOP structure to maintain, and you may want to end up creating your own exceptions as derivatives of these specific exceptions. So the basic syntax. Again, it's a try keyword with a colon and then an indented block of code that you want to have checked. So this is the code between the try and the except. That's the code that's going to be checked for errors, right? And then at this except block, you have except and then the exception type, whether it is a base exception, or something more specific. And then you use as E. And then here you can process the exception by printing E or looking deeper into E, say a stack dump. Or you can have different code that is doing something different to your program based on that exception and what was caught. You can also have an else block in there, which means that if an exception is not found, it will run this code. And then you have a finally block, and that means that whether or not it caught an error here, let's say there was no error in the try block, so it just executed, then it'll execute the finally. Let's say it did handle a specific exception that you called out, then it will run the finally block as well. But if this code runs and you didn't have a base class exception caught, then it's actually going to trickle up to the main runtime environment, and that's error handling mechanism, and it'll most likely cause a crash of your program. In that case, then the finally block will not run. So I'm going to showcase all of that for you now. Here I just had different examples of placing your try and except blocks within a function, as well as using a raise when a certain error could occur so that it would raise a specific exception, and so that you can use an external try except block in order to catch this error and then do something specific. Just giving you an idea that you can raise specific errors that may occur by having the checking mechanism within your function. And then here you have one with the finally block, and I'm going to alter this one down here just to show you what happens in specific situations here. So right now, this is the only little bit of code that ran, and it's just saying zero division error, and it's executing this line of code. So basically I had the two inputs being 10 and 0. It tried to divide by 0. It caught that zero division error, and then it printed the basic text behind that error. Cannot divide by 0, division by 0. And so what happens if I change it to a string 10? And so running it now, what ends up happening is a fatal exception. It trickled all the way up to the runtime environment's error handling mechanism, and it states that you can't divide an integer by a string. And so that's one thing that you need to make note of, is that if you're going to try to accept a specific error, which is oftentimes more useful than simply making a blanket exception, you would then have accept type error. And basically this gives you more specific information as to what this error and why it occurred, right? And if you always just did base exception, there might be some ambiguity as to, okay, well, what was the actual issue that I need to resolve? So it's oftentimes better to accept more specific first, and then you would have a final exception of a base exception if you were okay with this whole block of code failing and then having your program continue. So for instance, now it should catch type error. Yeah, so unsupported operand types. And so what I can also do here to showcase is use the finally block. And you'll see that even though a type error was caught via this line of code here, and then this was printed, it'll always run this code. Now, however, if I delete these two lines and there is a fatal exception, then it won't run. So that's something to keep in mind. So the finally will run whether this code ran perfectly or an exception was caught, but if an exception makes it all the way up to the runtime environment's error handling mechanism, then, and it causes your program to break, then the finally clause obviously will not run. So that was a brief introduction into error handling, and we overviewed try, except, raise, and finally blocks. Again, this is Grover, Blue Collar Codes, Quick and Dirty. Join us next time. Thank you.